Hello, Prop Stats, and welcome to 8.3. This is testing a claim about a mean. It's almost identical to 8.2, except instead of proportion, it's mean. Will be in the same place in stat disk, almost identically, and the process is about identical too. So let's go. All right, we're going to develop the ability to sample data to conduct a formal hypothesis test. So everything that we've been doing already. So we're hypothesis testing, except this time it's about a population mean instead of a population proportion. Now when we go through and do this, we have the same variables, n for sample size, x bar for the sample mean, sample standard deviation, and mean sub x bar is the population mean. Now, the sample has to be a simple random sample, so nothing new there. We have to have either or both, all right? It has to be or. It doesn't have to be both. The population is a normal distribution or n is greater than 30. So not both, just or, which is good. Now, we are going to do a test statistic for a claim about the mean. We can calculate this by hand. I will be using StatDisk, but if you're at home and don't have it or your internet is down, that is not a reason not to do your homework. To create this test statistic, you have the mean minus the population mean over the standard deviation divided by the square root of how many you have. Nothing too major. We will be looking at p-values and critical values. When you do the p-value, degree of freedom is the same. It's n minus 1. I will not be using the table. We will be using StatDisk to find the critical values for your degrees of freedom, which is always n minus 1. All right, when you're looking through here, is different for different sample sizes. So this is important. Your t-distribution, depending on your sample size, varies. So it's different for different sample sizes. It's not the same. The t-distribution has the same general bell-shaped curve as a standard normal distribution. So it looks like a normal bell curve again. Its wider shape reflects a greater variability. So it gets wider than your standard normal curve, which is okay. The student t-distribution has a mean of t equals 0. So your mean is 0, just like your standard. It varies with the sample size and is greater than 1 this time. So your t-distribution, unlike your standard deviation of 1, is greater than 1. Size n gets larger, it gets closer and closer to a normal distribution, which we set above. All right, let's do our example. So we have adult sheep here. Or adult sleep, I'm sorry, obtains time of sleep for random selected adults. Subjects included in the National Health Nutrition Examination Study. All right, so they've done this study. They have 12 adults. Their average sleep time is 6.83 repeating, standard deviation of 1.99. Okay, the common recommendations that adults should sleep between 7 and 9 hours. So this is what we're checking. We're going to use the p-value with a 0.05 significance level to test the claim that the mean of sleep for adults is less than 7 is what we are claiming. So let's go down here and see where we go. Is it a simple random sample? We don't know, but probably. Second requirement is that the probability is normally distributed or n is greater than 30. Well, n is not greater than 30. So we did not meet this criteria. So we have to have a normal distribution. So since we have to have a normal distribution, we're going to plug these numbers right up here. So get out StatDisk and type those into your data sheet. Okay, pause and get that done. Okay, once you've typed them in, we put them into column 1, click on data. Click on your normality assessment and see if it fit. Now you've got 3 different ways to check that. You're going to check your graph to see if it's bell-shaped. You can look at your normal plot, and you can look at the Reiner-Joyner to see if it matched also. So look at those 3 things and see if it is a normal distribution. Okay, if it fails to reject the null, the data has a normal distribution, which is what we're looking for. You have 3 different ways to look at that. Here are a couple. So we look at our histogram. Is that a rough normal plot? The answer is yes. That's not too bad. We're happy here. This here looks linear. We have a few things in here, but that's not bad for only 12 data points. So this is linear. And if you look at the Reiner joiner, it also said it was normal. So our normal distribution checks, and we can continue with our problem. Do not forget to check your requirements. Okay, step 1. We have to figure out what we're claiming. And we're claiming that adult sleep is less than 7. So we're claiming that adults are less than 7. The alternative is that they are greater than or equal to 7. So now we have to write our null and our alternate hypothesis. Null hypothesis always includes the equal. So that's mu equals 7. The alternate hypothesis is mu is less than 7. This is what we're trying to prove. I'm going to use a 0.05 significance level. Let's go up here. Okay, the claim is made about the population mean. The sample statistic most relevant to the test is the mean because that's the information we were given. So we are going to go to hypothesis testing, this time on StatDisk, analysis, hypothesis testing, mean for one sample. This is where you're at. So click on that and make sure you selected your sample data. We have 12, mean of 6.83, standard deviation of 1.99, population standard deviation is 7, that's what was given to us, with a 0.05 confidence rate. Analysis, hypothesis testing, 1, mean 1 sample. Now, enter the hypothesis test. This is how we put this in. So I'm going to claim, this is the alternate, this is not the null. The population mean is less than the claiming. So do adults sleep less than 7 hours? That's what we're looking for. We have a significance of 0.05. We're going to claim it's equal to 7. We don't know the standard deviation, which is fine. We had 12 or 13. Hopefully that's typed in there correctly. I'm going to hope it was 13. Okay, sample mean is 6.83, standard deviation of 1.9. So that's what we got from when we type this into StatDisk. We hit evaluate. When you do this, you're going to get a test statistic of t, your critical value, and your p-value, and a confidence interval. We're going to look at all of them just so we know how to use them. So now let's look at our critical values. We go here, our critical value is a negative 1.7. So that's over here. And this is our critical. So this is critical. And it is a negative 1.79588. So that means that this region over here is our rejection region. So if our test statistic falls in here, we reject it. If it doesn't, we don't reject the null. Well, the negative 2.89 is over here. Oh, I'm sorry. Negative 0.289. It is not in the rejection region, so we do not reject the null. The other way we do this is we look at the p-value. The 0.38869 is greater than 0.05, so we fail to reject the null with this one. Also, so we've got the same result. Our confidence interval is 7 in our confidence interval. And the answer is yes, 7 is definitely between 5 and 7.8. So again, we fail to reject the null. All three methods gave us the same answer, which is what we like. Makes life so much easier. Okay, so we've done 7. P-value is what I used on this example, where I want you to make sure you know how to use all three. We fail to reject the null, which means we conclude that there's not sufficient evidence to support the claim that the mean about an adult sleep is less than 7 hours. So we're accepting the null, which means we're failing to reject this fact. Doesn't mean I can support it. We're just failing to reject it. All right, your turn. All right, pause and do yours. You're going to use the shoe survey from our data, and When I did this, I just picked a shoe size and I picked a size 9. So that's what shoe size I'm going to be using, but it doesn't matter which one you use. You can get different answers. So pause and do all 8 steps. All right, I hope you did good. Your first thing should have been, what's the claim? And it was the mean shoe size is greater than 9. So what's the opposite of that? It's less than or equal to 9. Our hypothesis included the equal, so the mean equals 9. The alternative is what we want, greater than 9. We have a significance level of 0.05. The sample mean, okay, when I did this, could have been different than yours, was 9.75943 for me. I typed in the data, and this is what StatDisk gave me. So now we go down here. I had 53 people. My mean was 9.75943. My standard deviation was 1.2188. This could be different for you because your data has changed since I've used this. The mean of the population, we want that to be 9, and with a significance level of 0.05. We typed it in and it passed Reiner-Joyner or your bell curve or your normal distribution graph, whichever one you used. Okay, when we type this in, we got a p-value of 0.0002, which is less than 0.05. Means I get to reject the null. I'm rejecting the null, then there's sufficient evidence to support the fact that the mean shoe size is greater than 9. Now, if we look at our confidence interval, we are 95% confident that the mean shoe size lies somewhere between 9.4 and 10.1, which also demonstrates that it is greater than 9. I hope you did well. Okay, now let's look at our adult sleep, our critical values here. These are data from StatDisk. Okay, we're going to locate the critical value is negative 1.796. All right, so we got the negative 1.796. Here's my critical. All right. The test statistic of negative 0.29 fell over here. We've already talked about this a little bit. Since this is not in my rejection region, we failed to reject the null hypothesis. Now, use your shoe data to do the exact same thing. I want you to use the critical value now instead of the p-value method. All right, when you did this, you should be looking at StatDisk, and you should have gotten a critical value of 1.67, and our test statistic should have been 4.5. So now when you draw this, you're here, you have, oh, that's not good. That should be straight up and down. 1.67. So if it falls in here, this is our rejection region. Now when we look at our test statistic, it's 4.5, which is way over here. It's definitely in my rejection region, so we get the exact same results. We have to fail to reject the null, or reject the null, I'm sorry. Confidence interval. Okay, we've talked about, whoops, sorry. This one already too. With our adult sleep, we went through that. And then we looked at our confidence interval here, and 7 was between that. So we're 95% confident that 7 fell between 5.8 and 7.8. Now, use your confidence interval for your shoe data. So pause and try that one. And I think we've actually already done that. I did it on the last page. So hopefully you were looking at that. Okay, good luck with your homework. I want you to do page 196. You'll need StatDisk. Right here, don't forget to read this correctly. It's pick 2 problems that interest you between 13 and 28. So do not do all of these. Pick 2. All right, good luck and have fun.